which is moving. Okay, the question is like this. That means if t is the time period of oscillation, then for a pendulum, right? Then definitely what is the concept of oscillation? You know, my dear friends, that means if a pendulum is placed over here at certain point, okay, then if this is the length of the string, right, and pendulum is here, maybe from this position it is going to the extreme left, then again returning back, then going to extreme right, then again returning back. So this is treated as one oscillation, right? So for one oscillation, the time period is said to be the time period of oscillation of this pendulum. So this will be the extreme position to left and this will be the extreme position to right, right? The question here which is given to us is that the time period of oscillation, that means it's given that t, right? Now the question is that an obstacle is introduced just beneath pivot, right? So let me see if this will be the ceiling or reference through which the pendulum is hanged, okay, and from here this is the bob of the pendulum, right? Now an obstacle is introduced just beneath pivot, so this point we can say this is your pivot, this is your pivot, that means through which it is hanged, okay, that point. Now from this point this is hanged, and let us say the length of the string is L. Let us say the length of the string is L, right? Now my dear friends, here it's given that only the low, since the obstacle is introduced just beneath pivot, so if this is the pivot, let us say the obstacle is introduced so that the only the lowest quarter of string follow the pendulum bob. So that means if there are four portions of this string, this will be the first quarter, this will be the second one, this will be the third, and this will be the fourth, right? So let me write it like this. If this is L by 4, this is L by 4, this is again L by 4, then the last quarter is only hanged, okay? So we can say that yes, the obstacle is introduced such that here after the 3 quarter, so till 3 quarter it is hidden or it is restricted, the flow of the pendulum is restricted, right? Now with this we can say that only the lowest one quarter of string follow the pendulum bob. So this is the lowest one quarter, you can see this is L by 4, only the L by 4 is allowed to swing only, right? So after that this will follow till certain point over here, right? Okay, and then again this is the length L, this will go to this point, right? So my dear friend, the condition is that here you can see this entire swing, the question is that the pendulum is released from rest at a certain point. Let us consider this point is the rest, from here it is released, then definitely it will go through this way, right, reach to this point, and after reaching this point only L by 4 is allowed to hang over here, the length of the string will be L by 4 only from this point. So we can say if this is position A, this is position B, and this is position C, so length of the string length of the string length of string at A for this pendulum is nothing but entire length L, right? And at B the length of the string will be only L by 4, right? Why? Because it's given that an obstacle is introduced just beneath the pivot, right? Now only the lowest quarter of the string follow the pendulum bob. So this is only L by 4. This length is only used as a length of the string of the bob, and after this obstacle is restricting the flow, and then that's why only the pendulum will be swinging with the length of L by 4. This is also L by 4, right? So my dear friends, the question is that what is the total time period of oscillation of this pendulum, right? So you can see, if this is allowed to move freely like this, then the time period of for the oscillation will be equal to 2 pi root over L by G, isn't it? 2 pi root over L by G. But is it allowed to move like this? No, because only there are two portions which is followed by this pendulum. One is AB and another is CD. Sorry, BC. This one. For AB, the 50%, the length of the string is L. L. So for AB, the time period, the total time period of the swing will be the time period of AB and plus time period of BC, right? For the entire oscillation I'm saying, okay. Suppose this bob is moving from this place to this, then again returning back, coming to mean position, then going to extreme, and then coming back. Okay. So for the entire oscillation, 50% 50% will be happening for the 50% is happening for A to B. So we can say that this AB is covering only 50%. This is covering only 50%. Let me zoom a little. Okay, is it fine? Is it fine? Yeah. So from here we can see that yes, from A to B and then B to A, right? For this section, this is covering 50%. A to B, then B to A. And I've just splitted this entire revolution into two parts. Okay. A, B, A. So we can say A, B, A all together. Right. Then B, C, B. B, C, B. Right. But what we have considered both into two different sections. So this will be covered for the 50% of the oscillation. Right. Now, my dear friends, what is the time period of oscillation when the restriction will be only till B? This is only 2 pi root over L by G, isn't it? 2 pi root over L by G. And what is the for the section BCB? From here to here, the length of the string is only L by 4. You can see here, L by 4 is only allowed to be move because this restriction is here. So earlier the pivot was at point O, let us say. Now the pivot is at point D, right? This is the new pivot. This is the, we can, let me write it. This is the new pivot because for the 50% the pendulum will swing like this. Okay, after this 3/4 of the length of the string is restricted, and now the new length will be L by 4 only. With this L by 4 it will go to C, then again return back to C to B, B, C, B, B to C to B, right? So this will cover 50%. So that's why I'm writing over here 50% is covered for what? B to C to B, right? And 50% is covered for what? Tell me. This is covered to A, to B. After this is handed over to button, handed over to this part. Then again B, C, B is happening. Bob is going from B to C, then again B with a length of string L by 4. Then from here baton is handed over to this section, and now the entire length of the string will be L. Now remaining 50%, I mean to say remaining of the oscillation for this section will be happening, right? So A to B, then B to C, then C to B, then B to A. So then A, B, A is happening, right? So I want to explain it again, my dear friends, that this oscillation is happening like this. A, B, B to C, C to B, B to A, right? So this section is 2 pi root under L by G would be the time period of oscillation when the pendulum is allowed to swing with full length. But this is for 50% only, A to B and B to A. So that's why the time period will be 2 pi root under L by G will be the for the full. So this for 50% it will be divided by 2, isn't it? It will be divided by 2. And let me explain again that the action will be happening like this. First A, then Bob will go to B, right? Then Bob will go to C, then Bob will go to again B, then Bob will go to A. So from A to A this cycle is completed, right? So if we say the length of the string at point A is how much? At point A is L. See this. Length of the string at point B is before B. Okay, it is L, but at B, when it reaches B, it becomes L by 4. It becomes L by 4, right? Because only this length is available to swing, right? When it reaches C, the length of the string is L by 4, and when it again reaches B, the length of the string is just L by 4, but after this it will be L. So we can say at this point, let us see L. Let us write L, because already we have written L by 4 at this position, the first position of B. And when it reaches again back to A, it is again L, right? So this is happening. Hope you understand. At A position, the length of the string will be L. At B position, length of the string will reach to L by 4. At C, again L by 4. At D, at B again L. Then again at A, L. So entire oscillation is happening like this, right? Entire oscillation. For the entire oscillation we can say. Now, since A to B, then handed over to B, C, B, then again B to A. So this all covers 50% of the journey only. So that's why the time period of the oscillation will be 2 pi root under L by G divided by 2. Now, for this section, BCB, this section, I am saying this section, this one. You can see the length of the string is L by 4. So the time period of the oscillation will be nothing but 2 pi root over L by G, but instead of L it will become L by 4, isn't it? L by 4 root over of G, and this will cover only 50% of the journey. So that's why 2 will be dividing the entire time period, right? Now this will give you you can see 2 pi root under L by G is T. T is the time period of oscillation. So we can say 2 pi root under L by G when it is taken as common. Then under the bracket we are left with 1 by 2 here plus 2 coming out from here, 1 by 4. Here 2 is coming out. 2 multiplied with these 2 becomes 1 by 4. Right? And when you just simplify it, it becomes, this is 2 pi root under L by G is nothing but your normal time period of the oscillation. If you represent it by T, then multiplied with 2 plus 1 by 4. When you simplify the numbers 1 by 2 plus 1 by 4. So this will be giving you 3 by 4t. 3 by 4t. So my dear, total time period of oscillation is calculated, and this is equal to 3 by 4t, and 3 by 4t is your answer, my dear friends. So if I will show you, let me squeeze a little. So what is your answer, my dear friends? The pendulum is released from rest at certain point. How long it will take to return to that point? Which option will be correct? Tell me. Now we have solved 3 by 4t. So which option is correct? Option number B is correct. Option number B is correct. So this will be your answer, my dear friends. Right? So we'll come up with more numericals, with more conceptual problems, my dear friends. Thank you so much for watching. Take care. Bye bye. Take care and keep your preparations on the top. See you into the next class. Bye bye.